Good afternoon, everybody. My name is Brant Steen. I'm the CIO and CTO here at the college, so I oversee IT and technology and those such things. I would consider myself at the absolute maximum a 3D printing novice slash hobbyist. So luckily for all of you, we have 4 experts here who will speak to the topics that we have to discuss. At this time, I'm going to go down the line here, starting with you. Please tell us who you are, what company you're here to represent, and a little bit about your intersection with 3D printing.
Awesome, thank you so much. My name is Gina Scala. I am here with Allegheny Education. I am their account manager for New York metro area, but I spent the last 10 years at Stratasys. They're the global leader in 3D printing for sort of the high end. I was in their products team, traveled the world, worked with customers from India to Indiana and back, straight home to New York. Worked on a certification program for their education team to certify students in concepts for additive manufacturing across the 7 different types of additive technologies. So I'm really excited to be here representing the Stratasys perspective, representing Allegheny, and joined by some of my friends like Carlos here.
Hi guys, my name is Carlos Alvarado. I work with Formlabs. I've been with Formlabs about 8 years, and we've been with quite a ride. Evolution about the SLA printer, now the SLS printer. I'm happy to be able to speak to you guys about this. And I also have a background in architectural technology, so my interest in 3D printing came from architecture, and we've definitely come a long way.
Hi all, my name is Dan Insogna. I work with Phillips Corporation. We are a technology distributor for machining and additive technology. I've been in the additive world for about 6 years, exclusively with Phillips Corporation. We are experts in powder bed, SLS technology, metal, DED, direct energy deposition technology, and supporting accessories that go along with additive. Really happy to be here.
Good afternoon, everybody. My name is Larry Granec. I work with BOFA Systems. BOFA is a Donaldson company, very large worldwide filtration company. BOFA manufactures fume extraction systems, source capture fume extraction systems that are commonly used on and with additive manufacturing technology, 3D printers, as well as laser cutters. I am new with BOFA Systems, just started a couple months ago. My previous 10 years, I actually worked for a company very similar to the company that Gina works for now, a partner of a lot of 3D printing technology, as well as career in technology, education, equipment in the upper Midwest. So my experience with additive manufacturing, with 3D printing, comes originally from that. I was selling that type of equipment, doing teaching, training, service on that equipment as well. I ran the additive manufacturing competition for Skills USA in Wisconsin for about 6 years, I believe. And it's just a really neat technology that I fully support, and it's something that my experience is mostly in education, and it's a great place to get started.
Thank you all. Beginning with Gina here, let's talk a little bit about the current state of things, where we are today. What are you seeing right now in terms of current trends? What should people be thinking about when they enter into a conversation about 3D printing, or just if they're trying to get more general knowledge around the subject?
I think folks are starting to understand that there's more than one type of 3D printer. There's more than one type of technology. There's actually 7 core ASTM standard technologies, which are all represented here in some of the words that we've said already. And different technologies are for different purposes, right? We wouldn't put a really cool, colorful, flexible part that can't stand up to heat on an airplane because we would have a problem, right? We need something that can withstand heat and chemicals and so on if we're using it for aerospace. So I think as 3D printing has grown as a technology, and as the technology has changed, the knowledge that people have about finding the right type of printer for the right type of application, and then a step further, finding the right materials for that application is really important, and has become, I don't even want to say a trend, but a necessity for folks. We're starting to see materials like Formlabs has a silicone material that is a real material that's used in real applications. We're now able to print with it. So we're starting to see that those changes happen, and it's really, really exciting. Yeah.
Yeah, I would also, like on that note, I think we've come a long way in terms of the tools to help us 3D print. Software and scanners are very, very user-friendly nowadays and very advanced. I was looking at tutorials in the booth next to my table on how we're scanning products and being able to create a 3D model to print. So all those tools have become more accessible, more intuitive, and that's a big plus. We've come a long way, and now our hardware, our printers have to deliver. So I think we stand in a really good place for anybody that's starting or anybody that wants to upgrade and become an expert.
Yeah, I certainly agree with that. I think the increase for first-time adopters trying to figure out what technology suits you best, whether it's a small business or a large OEM that's been doing traditional manufacturing over the years, and they're trying to see, is there a better way to do this? Is there a more innovative way to do this? Work with a lot of folks that are on the smaller end, where they're 25 or 50 employees or less, and they're trying to figure out what equipment can I implement to diversify and attack another business. And as Carlos was saying, software has gotten better, training has gotten easier, the equipment has continued to get more cost competitive, the materials have gotten better, stronger, offering more flexibility for the user, and the more that continues, the broader the base for first-time adopters, which is critical to the market moving forward.
Yeah, the only thing I would add to that is really just reiterating what was already said, is that the variety of 3D printing technology these days is amazing. When I look back to when I first started to get involved with 3D printing and understanding 3D printing, and actually even in today's educational environment, the technology is quite limited. Only in the very recent years has there started to been an expansion of different technologies in education, especially the K-12 area today. The FDM has been around for a very long time. That's the first type of technology that the price point came down to a point where education was really starting to adopt it. And if you walk into a school today, 90 to 95% of the printers are probably FDM. But then you look at some of the new technologies that Formlabs offers, and they are being offered or being adopted by the K-12 schools more and more. So the wide variety of technology is amazing, and I'm happy to see that it's filtering down and becoming more accessible at the entry level. And then the materials, the new materials every day, all the time. That technology advancement is something to pay attention to, and something to start to understand more if you want to get involved in 3D printing.
Yeah, so it's becoming a pretty vast and diverse type of industry here. Let's bring it down a little bit and talk about if a person just getting into this, wanted to get into it for the first time, or they're curious about how, what entry points there are. There's lots of devices out in the market, lots of materials, as you've been mentioning, lots of acronyms. I think I've heard 5 or 6 of those at least already. So let's take it down to that person who's just getting into this. Carlos, why don't we start with you? Where might you have someone start? Where's a good entry point for somebody?
Yeah, so I mean, we're in a very exciting moment right now because there's a lot of FDM printers, DLP printers that are very affordable. Low-cost 3D printing is taking everything to a next level. It's great to see when people that, because obviously when it comes to EDU, it's all about the budget. It's all about making sure that the school can afford it. And in the past, we weren't able to offer a lot of options that were under $5,000 or $10,000, and now there's quite a lot. So for a customer to start looking and researching FDM printers out there, there's quite a lot, and there's a lot of them with a lot high print success rate. So and we're in a very good place.
Yeah, I certainly agree. I think I'll speak to the industry side. I think a lot of folks that are trying to spec their first machine, they're trying to figure out what machine works, what technology should I implement first. Service providers are a great place to start. A lot of precision shops, they're trying to figure out how can I tune in the part, what's the process look like. To have somebody that already has multiple technologies to run some test parts for you, show you what the prototypes look like, help you identify what your cost per part is, and then ultimately choose the technology that fits best for you. I think that's kind of an accelerated roadmap to get you to the point where you can have your own machine. That's usually the pathway that I try and steer folks to.
And I'm going to step back even more. I'm a mom of an 8-year-old, right? So I'm going to take this question from the eyes of the 8-year-old and a 3D printer and where to start. And with him, Mom, I want to print, Mom, I want to print. And Mom has access to all kinds of 3D printers, from ones that are $5,000 to ones that are $500,000, right? So yes, of course you can print, but you've got to design it first, right? And so where do I start? Do I go out to a Thingiverse or a GrabCAD or a 3D print something and download it and print it? Okay, I mean, that's like buying something on Etsy versus making it, right? I try from his perspective to say, if you can design it, we'll get it printed, right? Download a Tinkercad, get an Onshape, get a CAD program, get in there and make a simple object, and then I get access to an FDM printer because they're all over the place, right? And they're easy, and get that part printed. Start there. Understand what it takes to get something that's in your mind into a design program and out of a printer. From there, you can decide what type of printer wants to do what, right? And you can go deeper, and you can do beautiful parts with fine feature details, really super blazing fast out of a Formlabs, or you can do a durable part out of a powder bed fusion system that's going to stand up and be an end use part. But you really got to start at that workflow, that process of understanding idea to CAD to 3D part. And that's the advice I would give an 8-year-old, and that's an advice I would give a high school teacher starting out with 3D for the very first time.
I believe we have an 8-year-old in the audience, so
Yay.
your words should be. Anything to add, Larry?
So Gina knew what I was going to say. That's why she skipped me.
Oh, that's it. The end. Drop the mic.
We have to start with Larry next time.
Fair enough. So you've mentioned here a few times the education pieces of this, the engineering pieces of this, being that we are at a college. What kinds of education pieces do you think people should start with? What's kind of the fundamental level of, is it an engineering background? Is it a materials background? Is it all of it, right? Where's a good place if people want to get educated to help make an impact in this industry?
Larry, you want to take that question?
Okay, yeah. I'll start in a couple, because when I first was listening to the question, my mind went one direction, and then I'll go back a different direction. So first of all, and this kind of actually lends itself to the former question too, is like, where do you start? One of the ideas is helping, especially younger children, think in 3D, right? How do I design something in 3D? And the way most 3D printers work is you build up layer by layer, right? The software takes a 3D model, it slices it by layer, and then you're building it layer by layer. So before you even get there, most schools, and I've seen educators start this way, most schools also have laser cutters. So you can take a 3D model, slice it into layers, and cut it out layer by layer using cardboard, cheap, right? Using cardboard, and then they build that model layer by layer. It helps them to understand that you can think in 2D, you can think in 3D, and you can build in 2D and combine that together and have a 3D model at the end. So that's a very, very basic way, inexpensive. A lot of schools also have laser cutters to help students make that transition between, here's how even a 3D printer works. I'm starting with a 3D model, I'm slicing it layer by layer, and then I'm putting those layers together. Another direction I was going to say is, for education, that's a hard, in my mind today, that's a hard question to answer, because 3D printing and additive manufacturing eventually is, and I think of additive manufacturing, 3D printing, those terms are used interchangeably most of the time throughout the world. I think of 3D printing as the process of printing something in 3D. Additive manufacturing takes it to a little bit different level. You're manufacturing something, there's a term called DFAM, which is designed for additive manufacturing, which is if you're going to get to that level, those are different career paths and different education paths that you will want to go through. But back to the basics, if you just want to start 3D printing and get involved in it, it is part of so many different areas, from art to science, math, the whole STEAM terminology. Anything that you're manufacturing today, people are thinking about how can we do this using 3D printing, using additive manufacturing. There's a huge transition happening from traditional subtractive methods to additive. And not saying that subtractive will ever go away, but there's a huge transition in terms of how do we make it using less waste, being able to build it all in one part. And to start though, back to my original, I'm bouncing around here a little bit. There's so many different places that you can start that it's hard to pinpoint. This is the program you should take or go into to be involved in additive manufacturing. I have a degree in education. Did I ever think that I was going to be involved when I started that with 3D printing? No. But my life has evolved to that point, so there's so many different areas that you can go into that eventually you will end up being involved in additive manufacturing. It's hard to pinpoint one area. Of course, your STEAM areas are going to be good ones to get started with.
Yeah, and just to add, I think that, when we think of 3D printing, you automatically think engineering, right? Like that's something that it comes to your mind first thing. But when it comes to design and prototyping, I mean, you can implement prototyping into anything, really. We've worked with companies that are designing hardware for the kitchen to customers that are designing toys. So it's really unlimited the way where you can really get started. And when you think about your schools, for those of you that work in colleges or higher ed, if you have conversations with different teachers that along with you want to implement 3D printing, I'm sure you'll find a couple of champions that really want to support you. And once you get started with one champion, whether it's an art teacher, designer, a technologist, whatever it may be, then once you have that, you'll have a solution for all those applications, all those different programs.
Yeah, when I think about the most successful programs that are using 3D printing, it's not just engineering, it's art and architecture, it's product design, it's even the auto shop doing sort of customized, fixing a cup holder or doing customized modifications for one of the cars that they're working on. I see a lot of repairs happening in schools, doing reverse engineering to parts. Schools buy things and they have to keep them forever, right? And they've got this broken wipe-off board, and how do you fix it? Well, your kids scan, measure, and so on, and make that fix. So we see a lot of reverse engineering applications there. When we get into college, we see it in aerospace, automotive. We see art design, like heavy-duty art and design programs utilizing 3D printing in a variety of ways, certainly product design, and then medical. The medical profession is really, really in need of engineering, people with that knowledge of 3D printing, people that are able to go from an MRI model, like a DICOM model, into an STL to have a patient-specific anatomical model for surgery, or even on the medical device end, right? Stryker is right here in New Jersey. Stryker uses 3D printing to print a lot of their titanium hips, to do prototyping on the new hip models and so on and so forth. And they're always looking for people to come and who have that additive manufacturing knowledge. So putting those printers in your classrooms, utilizing them in the high school and feeding into college programs that have bigger and better and additional technology really paves a path for more than just a mechanical engineer. It paves a path for so many different professions.
Anything to add?
Anything else? No.
Good there. Okay. Let's talk about the consumer then for a couple minutes. 3D printing, at least in theory, opens up a lot of opportunities for customization, less expensive goods, quicker turnaround time, things obviously done on demand. Talk for a minute, and Dan, we'll start with you, about the consumer implications from 3D printing, where things stand today.
Yeah, so there's usually multiple reasons why a consumer's looking for additive. It's most of the time to solve a problem. It could be a material issue. I can speak to probably one of the biggest challenges right now in the industry is castings. The frustration of trying to find reliable castings and suppliers that can deliver on time, that give you the capability to machine your casting to a finished part and really maintain quality. That's been a big challenge, especially since the start of COVID. A lot of folks now have turned to additive, and they're saying, okay, if I don't machine castings like I used to, or I take a portion of hard to find castings or more rare materials, and I use something like powder bed technology to solve that problem, what does that look like for our business? And that's an avenue where you can start exploring. I can design a better part. I can design a more dense part, something that is repeatable, that's reliable, that I'm not dependent on supply chain or other countries. I can produce the part in-house or at a local service provider, and I can control that aspect of the business. So that's one avenue, is quality and control. Another one might be I want to reduce overall build time or part weight, or I want to have the flexibility to improve a line of components that I've been producing for a while. So I want to improve it or make it stronger or make it lighter, and you can do that with the technology that we offer. Those are two big, I would say, drivers to first-time adopters and even current users to continue to walk down the road of what should I look at next? What technology makes sense to really give me more avenues?
Yeah, real quick, I can think of two industries that right now the consumers are really taking advantage of 3D printing. The first one is jewelry. A lot of people don't know that the technology is at a point where you can really find really great detail, and it's great for for a customer to walk in a jewelry's workshop and start designing their dream ring or something they want to give to a loved one. And for them to be able to make their dream come through 3D printing and jewelry, that's one that goes really far away, and it's very exciting. And then the other one, similar to what Gina was saying, dental. So we've gotten to the point where the material development here at Formlabs, where we're doing biocompatible material, we're investing a lot in the science behind biocompatible materials, and certifications are coming a long way. The process is getting a lot smoother. So we now have material where you can print dentures and where you can print crowns. And that's something that I think we only dreamed of 5-7 years ago, and now it's a reality at different dentists and different labs. So it's happening.
Thank you. Let's talk a little bit then, move over to any regulatory challenges that you've all run into, anything going on in terms of interactions with governments or regulating bodies or anything else as it relates to this industry and it moving forward.
Well, I mean, certainly aerospace, there's a whole bunch of certification on 3D printed parts having to go into flight and what is needed there. They have made it through a lot of those regulations. The Airbus airplane, the big one that I'm not I ride airplanes. I don't know a lot about them, right? But there's about 1,000 parts in flight that are 3D printed on Stratasys printers in the the most common Airbus airplane. We had to go through a whole certification process to allow them to fly. Now, they're not flight critical parts, they're latches, they're those types of things, but certainly the FAA had a lot to say, and that took about a decade for that to happen. The other certification we're seeing is in medical and dental. I'm sure you have a lot to share there, as Formlabs has cleared a lot of those hurdles and continues to clear more, so that things like, even things like wearables are wearable, right, without too much of an issue. And then I think the other piece of regulatory has more to do with filtration and something. So I'm setting you two guys up to finish those comments. But 3D printing has come a long way in terms of being accepted as a regular use part. The Rivians all have 3D printed parts on. If you buy that today, you will be able to locate at least 6 3D printed parts on your brand new Rivian. So lots of certifications that had to happen on that end. Do you want to take a little more about medical? I know you know more than I do.
Yeah. So the great thing is the first steps have been done, right? Like whenever we design a material and we go through the process and the surgical guides versus denture versus crown, all these first generation materials have been adopted. They've been accepted. The great thing is the customers now have put it into place, they've put it into action, and we've got a lot more data now. So whenever we launch a next generation surgical guide material, it's gone through so many testings, and there's a lot of things that we've improved in the formula. So I think it's just gonna get easier, to be honest with you. I know the process is not fast because it should take a long time, right? It should be something that should be carefully analyzed. But in terms of availability and options, yeah, I think we've given the first steps. We've put it in the market. It's being used. It works. So now we just got to keep evolving.
Yeah, I certainly agree on the medical side. I know with EOS powder bed technology that we sell medical folks, it's on the cutting edge. It's always making sure that we can get through FDA approval or use the proper material for end use, and you spend maybe a year or longer trying to get the right part design, and you're through your 4th or 5th review, and you want to make sure that everything's right before you have your production part signed off on and you're using controlled material. That's definitely a hurdle. I think at a higher level too, just to talk about general industry, you go from machining a casting to 3D printing a casting. How can you be sure that the part is equivalent or better to the way that you used to do it? And there's a lot of different ways to go about that. Do you rely on the material data testing? Do you do destructive testing on the components and prove out that the part is equivalent or better in strength, which we know that it is compared to a casting? So I think at a higher level for customers that are just trying to replace an old style of manufacturing, that's even a hurdle, just to try and get sign-off from their end-use customer that they can print this part on a powder bed system instead of machine it out of a casting. So we see that at just a higher level in the industry as a challenge.
So we're kind of, did you have something you wanted to add? I thought you went for the mic. So we're seeing it across a bunch of industries here. Some obviously adopting a little faster than others. In some areas, obviously, it can bring, take medical things, for instance, it can bring probably that technology at a much lower price point to a much wider audience of people. All good things. So let's talk about the 5 and 10 year out kind of vision or predictions around here. And Larry, I want to start with you. Where do you see this industry going, again, in the 5 to 10 year time frames?
So I'll start by saying, like, I remember years ago, we were talking about 3D printing, and the answer was, or the thought was like, yeah, in 5 years, everybody's going to have a 3D printer in their house, and anything that they need, they're just going to 3D print. Maybe in 5 to 10 years from now, that might be true. We have a pretty good start right now getting there, where 3D printers are being found in more and more households, and they're being utilized in more higher level fashion by the general public. Where I see it going more quickly in the next, say, 5 years, so about a month ago, I participated in the AMUG conference, which is Additive Manufacturing Users Group, and we were there as an exhibitor. And across the exhibit hallway from us was a company called Worth Manufacturing, Worth Additive Group, and they launched a program there called Digital Inventory Services, and their motto is always in stock. So their vision is that their inventory is going to be switching over to a digital inventory, and if you need a part, it's always going to be in stock. And in stock being that you're either going to be able to 3D print it yourself if you have the capabilities and the correct materials, or you're going to be able to send it to a 3D print center and have that thing delivered probably within hours to you. And these are parts, they're big in the automotive, but it's all in industry parts. Their parts will be certified by the OEM. So if you follow the print instructions, if you use the correct printer, and if you use the correct material that is certified, you will have a part that's technically certified from the OEM. And you're able to get that within hours or print it yourself if you have the right equipment and the right material. That's where the software that they launched, the program that they launched, I was actually surprised that somebody hadn't launched that a few years ago. And if they have, or somebody tried to do it, I haven't heard about it yet. But that's where I do think this industry will be going in the next 5 to 10 years, is having more and more components. And Gina alluded to it earlier, saying, yeah, something breaks, you reverse engineer and you fix it. And not only that, but basically having, rather than companies stocking components, they're going to stock digital files. They're not going to we're not going to have warehouses filled with parts. We're going to have digital inventory, and we're going to print on demand when parts are needed.
Yeah, I agree 100%. We so at Formlabs, we just launched our new generation desktop 3D printer. And a couple of days we were having a discussion where we always get asked, is 3D printing or Formlabs, is it for prototyping or is it for production? And we've always focused on the quality that we are a printer, a company for professional 3D printing. And I think we're at the point where, since our previous generation 3D printer, we took a big step forward where you can actually print quality parts for end-use parts, as we've talked about different examples here. And we have the systems in place, we have the automation in place to be able to become a production 3D printing solution. And that's saying a lot, because when we were discussing maybe 3D printing 5 years ago, it was definitely only for prototyping. And if you wanted production end-use parts, you had to spend $100,000, $200,000. We're not at that point anymore. The science behind the materials has evolved enough where we can produce quality parts, and the hardware is there to become a production solution. We actually did a pretty cool test, and it's on our website, where I feel injection molding is the standard for making quality parts, plastic parts. And we took 4 desktop printers of the ones we just launched and 1 injection molding machine, and we decided to print who would get to 1,000 parts faster. And the Formlabs, the 4 units of desktop printer, beat the injection molding machine. So the video's online. It's a really cool test that we did. And I think we're at that point in terms of the evolution of 3D printing.
I think you're going to continue to see 3D prints in every aspect of your life. And what's going to enable that is, just like what Carlos said, just the materials that are available, the materials being, closer to materials that exist today. And speed. Formlabs has taken a huge step forward, being 4 times faster than they ever were. Some of the desktop printers, I won't name them by name, but are a lot faster than we ever expected them to be. And that speed to part and that speed to quality part is going to make it easier and easier for us to have 3D printed parts in every aspect of our lives. Whether that be, something made of production grade material in a vehicle we drive, or a piece of of chocolate that's printed for the top of our child's birthday cake last minute because mom forgot to buy the chocolate, right? It doesn't matter. I mean, all of those are applications that can be used. The other thing that I see happening, and I see happening slowly because it's in medical, is FDA approval for 3D parts. So that you can not just have an MRI model, but you could have a 3D, you can have a scan and a 3D model that helps your doctor make decisions on your treatment or helps you understand your treatment. And it's your actual kidney or liver or whatever it might be that is there. And speed will help that as well, because if you're sick and in the hospital, you can't be like, well, maybe in 3 days you'll have a kidney we can look at. You need that now. So all of that will help. And I think we'll see that 3D printing is not going away. It's just becoming more and more part of our everyday life. So, yeah.
So how about either a problem or maybe an industry, and Dan, we can start with you, that's been slow on the uptake, that 3D printing could really help, but hasn't really made its way into either that industry or solving that particular problem just yet?
Yeah, I think it's always a challenge with first-time adopters. I think the barrier to entry has been difficult in the past. Industrial machines have certainly come down in cost, but there's still a substantial cost for your first machine that typically you need to get the desired cost per part. I think precision machine shops, folks that have been cutting metal for a long time, a lot of those guys, they're the best ones for jumping into additive from a standpoint of they have the post-process nailed. They know how to post-machine parts. They know how to finish material. They know how to handle it, and really they need just training on the front end to understand how to design for additive and how to operate the equipment. It's getting better. There's opportunities out there to help first-time users get in the game, whether it's supporting DoD opportunities or partnering with education, even going after and partnering with other corporations to try and do like a joint effort. But I think that has been the slow spot. I live in Pennsylvania myself, like to call Pennsylvania the land of making stuff. There's a machine shop around every corner, and there's highly skilled folks in those machine shops. And I think the more that we can help jump that barrier to entry, the faster we'll build a much broader base for supporting manufacturing in the U.S. And I think everybody is pretty darn excited for that. And that would support not just the standard technologies, but really the broad base of options that we're all discussing, whether it's Formlabs or it's EOS or it's Meltio or Phillips Hybrid or what have you. It opens up that opportunity for multiple technologies to support different tasks inside these types of organizations.
I think schools, right? I think schools could do, we in education, I'm a former teacher before Stratus, could do more, right? We sort of check the box. So we've got an FDM printer. We're doing 3D printing in our school. Well, there are 6 other types of technologies that we could be introducing. Maybe we don't own all those printers, but we're teaching that, right? Maybe we take the jump in and we add a Formlabs, or an SLA printer next to our FDM printer, or, hot glue gun style, and so on. I think there's so much more we can be doing, certainly at the college level, maybe a little bit at the high school level, to dive deeper into 3D printing, dive deeper into the technology. Our students are buying them and using them at home, right? Our students are doing crazy things. I'm the national chair for Skills USA for additive manufacturing for 3D printing. New York, New Jersey, and Pennsylvania almost never send a student. I like to see our states represented. I'd like to see us do more and get sort of with it, because the middle of the country, guys, are all 3D printing. They're all sending their kids. They've got big printers. They've got multiple printers. We're a little, the Northeast here, we're a little behind in terms of that technology.
So I've driven through 8 states in the last 3 days. So if we could figure out how to 3D print roads at a rapid pace, I think we should do that.
Are you saying the potholes? Is that where you're going with this?
A lot of construction.
Construction.
A lot of potholes, a lot of construction.
I guess it depends on the 8 states you've been through. Yeah, so brought up a few times here around certain barriers, both at the consumer level and at the business and industry level. Talk a little bit about some of these barriers that you are seeing out in the work that you do, and also how to overcome them, or what you're seeing in terms of pushing through them. Sure. So this is about the barriers to entry into this industry, about getting in here for the first time, either as an industry or a business, or at the consumer level, however you want to take that.
I'll take two different things. Number one, change. Change is hard. So there are a lot of times I feel the barrier is people just used to doing it the old way and they don't want to change. Second of all is probably a trained and qualified workforce. Everybody's fighting for. I mean, you go to a school like this, and every department is fighting for students. So having students pick the career pathways that will have them qualified to get started or to take a job in industry and say, hey, why are we doing it this way? Why aren't we using a 3D printer to do this? Why aren't we using additive manufacturing to do this process? We could do this so much better. We could build jigs, fixtures. We could increase our production. We could make our shop floor safer with ergonomic tools assists, right? Assists. So what are they called?
Jigs and fixtures.
Jigs and fixtures. Thank you. Gina's so smart. So I think there's that, is having the educated and ready workforce ready to make that change. And then this is changing rapidly, but the ROI, the investment, like, for years, and honestly too, like with your high quality, really high production, new material, advanced material printers, they're still expensive. So there is that understanding of how important it is to make that leap and make that investment, and what that return on investment is. That is hard because it's new.
Yeah, I'd like to add kind of something I feel all of us has been talking about here. So there are a lot of people that are probably not experienced with 3D printing that are still intimidating by 3D printing. And it takes one or two champions to really, go over that hurdle. And whether it's an entry-level 3D printer to a more professional 3D printer, there are ecosystems in place that really have the solution completed with hands-off. And it's not like you need to take a course or take a college course where you need to be there for months on training. No, we're not at that point. So that's a barrier that I feel that we could easily overcome through education, right? Through customers educating themselves, through us as companies putting content out there, trainings, webinars, whatever it may be. But we're in a place right now where the solutions from beginning to end are hands-off, and you don't need a certain amount of years of experience or very intense training. No, we're not doing that. So that's a barrier that I think could be easily attacked and overcome.
So one more question, and then I want to move on to some final thoughts from everybody. Question is around another emerging technology, and if you have any thoughts around how this industry is dovetailing or may dovetail in the future with AI and its increasing prevalence in our society.
Someone brought up lightweighting earlier as a benefit of additive manufacturing, right? So if you think about a bicycle, if anybody watches Tour de France, those bikes, the lighter they are, the better they are, because they can go faster and so on. Same thing applies to racing cars and to airplanes and so many other industries. And where we see AI is in the technology. So we'll take a part that was traditionally made, maybe it was machined, maybe it was 3D printed, and we'll run it through software that does some generative analysis, and it will take pieces of the part out that are no longer necessary. And you'll find this part with strange holes in it or lattice work or so on, and it's structurally just as strong, but it's half the weight. And so we see AI layering into this type of topology optimization and this type of lightweighting of parts, and it's reducing the cost of the part, it's reducing the time to part, and then it's making the end easier and better. So that's one kind of tangible example I have of AI helping with additive.
I can think of design. I think we've gotten to the point where design, I don't think the CAD software is getting any easier to use. And I really see it. I really see you describing to ChatGPT, design me a gear with this specific solution I'm looking for. Give it the data that you need, give it the measurements, you can even give it like the problem. And I could really see it happening and making design of 3D models and CAD models a lot easier.
Yeah, I think to take it a step further, I agree, AI is definitely doing all those things. When you look at machines going faster and platforms getting larger to accommodate more parts, then you couple in AI to lightweight the parts and make them optimal to the point where the original engineer never could have. And then you pair those two items with automation, and now you have a system that can run without human intervention, that has the most ideal part that's been modeled to run on that particular platform, and it runs in a manner where it's lights out. And now you start moving into a conversation of what does it look like when you have a factory full of 6 or 7 different technologies that are all running parts repeatably, that are loaded and unloaded using automation, with parts that are designed using the latest and greatest AI software for lightweighting. You end up with a whole different look at manufacturing in the US. And I think that's my answer to what does it look like in 5 and 10 years. That's where I see the market driven to allow us to run at the rate that we need to run at. And really the magic in it all is the design from the human aspect to build the infrastructure for it to run. So it doesn't require the person loading and unloading the machine. It's all of the foresight and all of the thought process to make all that run. I think that's really the answer. I think that's what I see in the next 5 or 10 years.
Thank you.
One more thought when you said about CAD. I don't know if CAD will get there. I've seen 2D give way to a lot of the advances in 3D, right? I've seen, inkjet heads used in polyjet 3D printers and so on. And we're seeing now 2D design in Canva, in Illustrator, start to add in AI. So it's just a matter of time before, so 2D CAD has it a little bit as well, that 3D CAD will have it. So I think that's coming. I just think we haven't seen it just yet. Yeah, it would be great. It would be great for all of us.
But it's so easy to use. Thank you. Just one to the table. We'll start with you, Larry. Just final thoughts before we close out.
We're in an exciting time. The changes that have happened over the last 10 years that I've been involved in additive manufacturing in some way, shape, or form have been astounding, and where it will go from here, I'm excited to see. I'm a little bit scared of AI, so not just kidding. No, I do agree with everything that was said about AI, especially if we could get that working in the CAD software. But other than that, it's going to be an exciting time. I think the changes coming forward will, and the advancement in what we've talked about today, the different technologies, the speed. Speed has always been one of the, thinking more about that, speed has always been one of the challenging factors of 3D printing. In fact, when I was selling 3D printers and laser engravers, and I always remember, like, a 3D printer is really cool to watch for like 5 minutes, and then it's like, okay, perfect. And then you go with the lasers, and the kids would sit and watch it, and it'd finish its job in 5 minutes. Oh, cool, and they walk away with something, right? And then 4 hours later, they go back to their 3D printer, it's still not done. But the speed at the way 3D printers are advancing is important, but also the material qualities in what we're doing today with materials is very exciting. So it'll be interesting to see where that goes in the future.
Yeah, totally agree, Larry. I think we're certainly in an exciting time. I think there's a tug and pull going on in the industry that I've certainly felt and seen. I think workforce development is can't be any more important. Trying to help colleges and universities and technology schools bring on the right technology to be able to train the next generation to go out and support and grow the industry and help companies become successful at integrating AM is really what we're trying to support, whether it's hosting events to get visibility or having training seminars or trying to link partnerships together so folks can buy equipment and use it and support industry. I think the other side of that is the growth needs that. Industry doesn't have the workforce currently in place to be able to scale AM to the point where we need it to be able to really push through and grow. And it starts with the workforce. When I was in college, AM really wasn't a thing. There were a handful of printers around, but not like it is now. The opportunity for young people has never been better. I probably spoke to 50 students out on the floor today. I think 10 of them at least told me they had printers in their house. They talked about DFAM, so they were already designing for additive, and they were turning off parts in their bedrooms or in their workshops. So as Gina said, they already are interested. So what can we do to get them in front of machines, small machines, production machines, to really drive the ball? I think the industry certainly needs that and wants that. I think that's the challenge we have at the moment.
Yeah, my final thoughts is I just want to challenge all of you to research, to study. Don't settle for the solutions you have right now. There's a lot of advances out there in 3D printing and design and software. So research, study, find ways to get connected to 3D printing communities. I love what Dan mentioned earlier about service bureaus. A lot of times that's where it all starts. You don't know what you know until you test it out. So if you have a problem, if you feel there's something that you could do better or a colleague is doing and you can implement it, do it. It's always scary when somebody settles for the old ways or an old tooling. Challenge yourself to implement yourself into this exciting market.
There's a lot of power in look what I made, right? And a lot more power, look what I made in school, look what I made with my classroom, with the technology in my school, but look what I made. If you yourself haven't followed the process through and 3D printed your own first part, get out there and do it. If you've done that already and haven't done it on another technology, get out and modify your part and do it. But have that, look what I made. I still have my first 3D printed part. It's called the Evolution of Man. It's like a little Candyland figure. The first one failed, the second one didn't stand up, the third one was too fat, and the fourth one was just right. So look what I made is really powerful. So just get out there and use 3D printing and make something.
Thank you all very much for your time and expertise today.